So in this video, in the chapter of electronic structure of atom, you are going to learn about photoelectric effect, and you will know what is the threshold frequency is, and the two equations you will be needing in this chapters are also given there. So now let's go further and learn what is photoelectric effect, and we'll do some questions on photoelectric effect. So just consider a nucleus, and I've shown some 3 electrons around it. And we know that these electrons are bound by energy, and that is the binding energy. And suppose a photon with an energy E2 hits the atom. This energy E2 can be represented as E2 equals h nu. So when this happens, either E2 can be equal to W. In that case, electron gets knocked off. If E2 is less than W, actually nothing happens. And the third case, when E2 is greater than W, this is an important case. So in this case, what happens is an electron gets knocked off and it acquires a kinetic energy. So apart from the two energies which we have been talking about, E2, the energy of the photon, and W, the energy of the with which the electron is bound to the nucleus, and it is a third energy, the occurred energy, the kinetic energy. So the relation between all these 3 energies is given by the equation E2 equals kinetic energy plus W. And you know that E2, as we have defined as h nu, E2 is h nu, and W, which is also an energy, can be defined as h nu 0, where the word nu 0 we call it as the threshold frequency. And rearranging it, we can get that kinetic energy is equal to h nu minus h nu 0. This is an important equation, and you will be doing a lot of questions based on this. Calculate the minimum frequency of light that's required to release an electron from metal, and the binding energy is also given. So this is the case, we just want to knock it off. That means the energy with which we have to hit the nucleus is equal to the binding energy, or in other words, the kinetic energy is 0. So we'll use the equation h nu equals 0 plus W, and h is given, W is given. So you need to calculate the value of nu, substitute all the values, and get the value of frequency. Calculate the kinetic energy of an ejected electron if a light of wavelength 358 nanometers strikes a metal, and the binding energy of the electron is also given. So in this case, since they have asked you to calculate the kinetic energy of the ejected electron, use the same formula. Kinetic energy equals E2 minus W. E2 is not given, but the wavelength is given. Therefore, substitute E2 in terms of hc over lambda, and W is given, lambda is given, we know h and c. Substitute all the values in and get the value of kinetic energy. And as usual, remember to convert the wavelength from nanometer to meter. An electromagnetic radiation of wavelength 287 nanometers strikes a metal, and an electron with the kinetic energy of 3.85 10 to the power of negative 19 joules is ejected. What is the threshold frequency of the metal? So use the same equation, but I have represented the equation in such a form that you can see the threshold frequency. Nu 0 is the one they have asked for, and kinetic energy is also given. Nu is not given, but it can be calculated because the wavelength is given. The detailed steps of calculation is given over there, because it is easier to calculate and you will make less mistakes if you calculate the way I have shown. Take out the h, which is common between nu and nu 0, and then bring the h to the kinetic energy side. So and then since the nu is not given, you calculate it using the velocity of light and the wavelength. Convert the wavelength into meters, and after you calculate all these things, the whole equation becomes simpler. It will be a simple subtraction, and the threshold frequency mu 0 can be calculated. So the question is not difficult, but some of the care you should take is work out at least 1 or 2 questions on it, because students usually make mistakes in parentheses and taking out of the parentheses. And nu 0 is the threshold frequency. Nu is the frequency with which the light strikes. If these basic factors are clear, you will never go wrong in such questions. Calculate the wavelength of light that strikes a metal with a threshold frequency of 2.84 10 to the power of 14, and it ejects an electron with a kinetic energy of 5.48 10 to the power of negative 19. We are going to use the same equation. So in this case, nu 0 is given, and they have asked you the wavelength of the light. So what we can do is we will calculate the frequency nu using this formula, and we know that from the value of frequency we can calculate the wavelength using lambda equals c over nu. Therefore, the question is pretty simple. Substitute the value of c and the calculated nu and get the value of lambda, and report the value of lambda in nanometers.